Okay, so we're looking at the working out for 2022E. The equation is written at the top. I've only written really the parts that we're interested in. This one is the daddy because there's a lot of points to this. So the first thing we're going to do is what we always do. We write our ratio as moles. So it's a 3:4, and I'm not showing up on the equation the 1:4 at the end. We find our information from the question. So when I'm doing this one, I have 3.16 grams of KMnO4. I have 1.5 centimeters cubed of phenylmethanol, and I have a density of 1.04 grams per centimeters cubed. And I read down through everything. It says, show by calculation whether there's sufficient potassium manganate to oxidize all the phenylmethanol. So that's a limiting excess thing that we're trying to figure out. And the other giveaway that it is a limiting and an excess thing is we have two pieces of information for reactants. That's only ever going to happen is if it's an excess and limiting. And the second thing in part 2 it wants to know is it wants to know the theoretical yield of this. So how do we go about doing this? We need to find moles of both of these things, the KMnO4 and moles of your phenylmethanol. So I'm going to look at the KMnO4 because that's the more straightforward one. So we have a K, we have an Mn, and we have an O4. K is 39, and N is 655, and oxygen is going to be 16/4. When we add all those up together, that should give us 158. So I'm going to divide 3.16 by 158 to get me my moles, and that's going to turn out at 0.02 moles. Over here with the phenylmethanol, I have a centimeters cubed. There's no mention of RTP or STP, so there is no volume triangle, and the density here, as we keep saying, is hopefully is making you think I need this triangle. So we are going 1.5 by 1.04, and when I do that, I get 1.56 grams of my phenylmethanol. I need to work out my molar mass for my phenylmethanol, so C6H5CH2OH. Ooh, did that wrong? H2OH, so it's going to be 12 by 6. It is going to be 1 by 5. It is going to be 12. 1 by 2, 16, and 1. And when I add all those up, I get 108. So I'm going to divide 1.56 by 108, and that's going to give me 0.0144 moles. So we now have to work out which of these reagents usually is in excess and it's limiting. But it tells us in the question that the KMnO4 should be in excess, because it says, show by calculation whether there's sufficient potassium permanganate to do it. So this implies that this is in excess. So what do we do? I'm going to use the 0.02 and we're going to apply our ratio. Okay, so if I have 0.02 moles of KMnO4, which is 4 equivalents, and I want to find out how much I should have of my phenylmethanol, in terms of a ratio, this is what it is. So this is what I need to have to use up if I have all of this. And what we're doing now is we're comparing, this is what I need, this up here is what I have. So I don't have enough of my phenylmethanol because there's a difference between these two numbers. So this means that this is the limiting reagent. It confirms that my KMnO4 is the thing that is in excess. And the rule is you're always rewriting your moles ratio with whatever is limiting. So there is not enough of the phenylmethanol. That means all the phenylmethanol is going to be made into product. So we will know how many moles of that there is. So I have 0.0144. I'm doing this in my head, so I'm not going to do it well. Find a calculator. So apologies for the delay. So 0.0144 divided by 3 is equal to, multiplied by 4 would be 0.0192. This will be 0.0144. This will be 0.0192. This will be 0.0048, and finally there's the other 4. But we're not going to need those for this last bit. So we have rewritten our ratio as our moles, and this is the number over here that we are interested in. We need to calculate a theoretical yield of this. So again, we need to turn this into grams of 0.0144. So up here we are going to write our C6H5COOH. So that will be 12 by 6, 1 by 5, 12, 16, 16 and a 1. When I add all of those things up, I should be getting 122. So I'm multiplying this number by 122. When I do that, I should get 1.7568 grams. I am going to look at my question for significant figures. So up here, 3 significant figures, 1.04 is 3 significant figures. So I'm going to turn that 1.756 into 3 significant figures. So I'm looking at here. So 1.76 grams is my theoretical yield of benzoic acid.